Hello everybody. So we're going to do a quick video today just to talk about two different 3D shapes that we might come across. One of them is the cone and the second one is the frustum. So I'm sure we've all heard of a cone before, so we'll start with that. Cone is like a triangle that's been rotated around to create a circular base. Probably know them from cornettos and traffic cones and similar things. You can look cones up on the log tables. The formula involved are pretty straightforward. We have a volume formula, which is a third times pi times the radius squared times the height. And we have an area formula. So the first thing I just want to point out here, that could be used to catch people out, is the area formula. Very similar to the cylinder. This is only the curved surface area. If we want to get the total area of a cone, we need to think about what the net of that cone would look like. So the net of a cone will have the curved surface area, the part that makes up the outside of the cone. We'll also have a circle at its base, or on top if it's an upside down one, like our cornettos. So the area for the top part, or the curved surface area, will be pi or L. And then for the circle is going to be the same old circular formula, pi or squared. So if we wanted to get the total surface area, we would have to add pi or L and pi or squared. So now we have enough information to solve equations that use the volume of a cone, use the curved surface area, and that use the total surface area of a cone. Again, if you want to solve a question like this, you just use the 4 steps that we've talked about before. Step 1, identifying the shape. Step 2, deciding which formula you're going to use out of these 3. Step 3, filling in what you're given in the question. And step 4 is just solving that out to find your unknown variable. There is a second way that I can anticipate them trying to trick you here. And it's one that we do see semi-regularly. The way this can happen is they will give you just one of these dimensions, but not necessarily all of them. So they might give you the height and they might give you the radius, but ask you to calculate the curved surface area, so you need to find this outside length L. So if we look at the cone sideways, it'll look like a triangle. Now we said that we've been given the height, so we can imagine the height being here. And they're giving you the radius. So if you had to find L, what you could do is just use Pythagoras theorem to find that missing dimension. Remember that the hypotenuse squared will always equal to the sum of the other two sides squared. So this will let you find the other one if you're only given one of these. Sometimes people will get caught out and they'll fill in L instead of H or vice versa, so just make sure that you're getting the right one. The height of the cone is from its base to its tip, and L is the outside length of the cone going from its tip all the way down to the outside of the circle. So now we'll look at the second shape of this video. A frustum is a shape we probably have not heard of before. So I'm going to get you a picture of a frustum now. A frustum is just a section of a cone that's had the top of it chopped off, so that the bottom is parallel to the chopped off section on the top. And if you want to imagine there being a imaginary top to this cone, that's what we're dealing with. The trick with dealing with a frustum is recognizing that for any area measurement that you take or any volume measurement you take, what you'll need to do is calculate the area of a complete cone, then calculate the area of the cone that's missing, and take the missing part away from a full cone. So we'll have a look at doing that now. So we'll look at this frustum here, and we'll say that I had an original volume of 10 centimeters, and we'll say that the portion that is kind of now missing, which we'll draw in red, is 4 centimeters. if we are asked to calculate the volume here, what we want to do is find the volume of the entire cone and take away the part that's essentially missing now. So the volume of the whole thing, the volume of the smaller section, then we'll take the smaller section away from the whole thing to just be left with this section here. So let's start off by calculating the volume of the whole cone here. So we've identified the shape as a cone. We're going to write out our formula. So we'll consult our log tables for step 2, writing out the formula, and we see the volume is equal to 1 over 3 pi r squared h. Then we can move on to step 3. We start filling in the values we know. We'll try and get pi as a decimal this time, and we'll give our answer to 1 decimal place. And you'll always be given this information in the question. The radius of the bigger section is a place where we get confused. So we have to remember for the bigger cone, the absolute radius is 6 centimeters. And the height of the bigger cone is 10 centimeters. Bidmas tells us that we should do our indices first. So we'll square 6. Then we'll move on to our next step, which involves multiplication of terms. This gives us a value for the volume of 376.8. And our unit for volume here will be centimeters taken from the question, and volume is always cubed. We now want to find the volume of this smaller imaginary cone here at the top, the section that's missing from the bigger cone. Again, the formula for the volume is going to be the exact same because it's a cone. So it'll be 1 over 3 pi r squared h. Now we move on to filling in the values that we know. For this smaller cone, keep pi as 3.14 in a decimal form. The radius for the smaller cone we've said is 2 centimeters, so it will be 2 squared, and the height is 4 centimeters. Again, Bidmas says that we should do our indices first, so we're going to square 2 to get 4. When we calculate at the multiplication stage, we get 16.7 centimeters cubed. Now we said from the start our plan was to calculate the total cone, take away the missing section, and we'll be left with this bottom of the frustum. So let's do our subtraction now. The bigger cone, 376.8, take away 16.7, leaves us with a total volume of 360.1 centimeters cubed. Remembering volume is always in cubed. This will give us the volume here of the frustum.